Time to look at regression versus classification. We need to be clear on when to use regression machine learning algorithms and when to use classification machine learning algorithms. Okay, let's start with regression. Regression is a group of machine learning algorithms that predict data when the target column may take on a range of continuous values. Regression is quantifiable. So it answers the question, how many, how much, how often? Target columns that use regression algorithms include height, as height could take on a range of values. Conceivably, there's no limit to those values. Distance, which is similar. And when I say there's no limit, I mean, we all know that like you can only travel so far, people can only be so high, but you know, the precision could conceivably be anything. Like there could conceivably be any number of decimal places. Revenue, again, range of continuous values from negative to positive, actually. Actually, you can't have negative revenue, negative profits. And population, okay? So these four all would fit regression because they all have ranges of values that could be mapped to a straight line. Now let's look at classification. So classification is a group of machine learning algorithms that predict data when the target column takes on labels or few discrete values. Classification is label-based, not quantifiable. Target columns that require classification algorithms include color labels. Note that there, even if you had quite a few colors, it's not really quantifiable, right? A regression line from like many different colors, even though there is a color spectrum, would not be ideal. Labels would be classification. Binary image recognition. We have labels and also binary, so only two, like cat or dog, your face or someone else's face. Height over 6 feet. Now, this is very subtle. Previously, you saw height in general is a regression column. That would be like you have a range of different heights. Okay, but in this case, height over 6 feet is actually a yes or no question. Okay, and so you can usually tell this by looking at the target column. If you have a bunch of yes or no's or zeros or ones, that's classification. Unlike a bunch of numbers, 5.78, 5.234, right? That would be regression. User click on ad. Again, that's usually a yes or no. Okay, example 1. The target column is how much people pay for an Uber or Lyft ride. Is this regression or classification? So take a minute, think about it. Go ahead and put your answer in the chat. Don't be shy. We're all learning here. Regression. Why? Well, the target column is continuous and quantifiable. Maybe you pay $5. Maybe you pay $13.27, right? There's not really like a limit to the amount that you can pay. And again, even though payment is not technically continuous, it has no upward limit, and many decimal places are welcome, right? So it's not a label. It's not like $2 or $4. It's like, hey, if your prediction gives 2.731651, well, you can round that, okay? So this is definitely a regression. Highlighting, by the way, what makes it continuous, quantifiable, in many decimal places. When you have those pieces in play, it's most likely a regression. Okay, now let's look at example 2. The target column is whether a book review is helpful or not. What do you think, regression or classification? Take a moment, put your answer in the chat. Classification, okay? Why? Well, the target column is discrete with only 2 labels. The target column with only 2 labels is always classification, okay? And in this case, highlighting the 3 key pieces, when you have a column that's an or, it's usually this or that, that's usually classification. discrete, often the case if it's very few, and labels in general. So 2 labels definitely. Okay, let's look at example 3. Student grades that range from 0 to 20 integers only. This is a little tricky, I think. So take a moment and think about this one. Regression or classification. I will give you a moment on this one. Yeah, I don't think it's obvious. I really don't. Even from what we've gone over so far, we're going to find out that there may be some edge cases. Okay. So what do you think? Is this regression? Do we have a range of continuous values that's quantifiable, where any decimal is okay? Or is it classification, more label-based with very few values? I haven't said what's few, so that could be tricky here. Okay, so regression probably works best here. Why? Well, even though discrete, the grades are quantifiable. They're orderable. They answer the question, how well did somebody do quantitatively? Regression can be used to find the best value and then round it, right? So you could have a regression line, a score of 13.25, and then you could round that to 13. So 3 keys here that could indicate regression are range, quantifiable, and rounded. By the way, I did something like this once and actually tried classification first. It's the Portuguese data set. I think it doesn't quite go up to 20. Okay, example 4. Star ratings between 0 and 4 integers only. What do you think, regression or classification? Again, I would say this is tricky. So take a moment, think about it, put your answer in the chat. All right, let's just jump in and I'll tell you what I say. I say experiment, okay? Why? Well, regression is possible because the values are quantifiable and ordered, right? If it's between 0 and 4, a value of 3.28715 could easily be rounded down to 3. And that's clearly greater than 0 and less than 4. However, classification is also possible because there are only 4 discrete values. So it's very common with 0 and 1 to use classification. What about 0 to 4? Well, you could use classification, okay? And I would say in this case, and in general with machine learning, that experimentation is the name of the game. If you can get better predictions using one or the other, I would go with that one. And it's absolutely okay to try both in an edge case like this. So, experiment. I also mentioned that we do have a Google Forms quiz on regression or classification with more examples that you can check out. Okay, because you really want to get these down. And final tips to help you with that. Regression or classification is usually a clear choice, contrary to those previous 2 examples. If in doubt, experiment and ask your community. And for the summer, that's your cohort leads. You can ask your peers too. All regression data sets may actually be turned into classification. What? How is that? It's called pandas. So just find a place to split the data. For instance, was the cab ride over $10? Yes or no? When you do a new column that creates that becomes a classification column. And you may find better results here. And your work actually may end up being original. Okay? Sometimes when we use the regression data sets, like the bike rentals data set, that's a famous data set. Okay? A lot of the ones that we use at Berkeley Coding Academy, and they're public, so they are. But you can actually make them unique by defining an original classification column. Happy coding!